Okay, we're going to talk about significant figures today. Significant figures are a set of rules for rounding, so we don't give answers that are more precise than possible by the equipment we've been using. So we have a standard for rule or for where to round when we're dealing with the answers to problems. And many people have problems with significant figures all the time, in chemistry especially. So, we're going to go through the rules of both what is significant and what is not significant, and then we are going to talk about addition and subtraction and multiplication and division, and then we're going to do a few example problems of the math part. Okay, rule number 1. All non-zero numbers are significant. So, in that case, any number that is between 1 and 9 is significant. So 123 has 3 significant figures. They are all non-zeros. Rule 2. Zeros between significant figures are significant. An example here would be 103. The 1 and the 3 are both significant because of they're a non-zero, and then our 0 here is between two significant figures, so it is also significant. Another example would be 1003. Again, the 1 and the 3 are both significant because they're non-zeros. Therefore, all the digits between that are zeros are also significant. Rule 3. A 0 or any 0 to the right of a decimal number is significant. An example here would be 0.0050. So the 5 is significant because of the of rule 1. It's a non-zero. And then this 0 is significant because it is to the right, which means that's a measured spot. It is to the right of the to the right of a significant figure in a decimal number. So what about these 2 zeros? Those 2 zeros are not significant because they are considered space holders. So they tell us that our measured number is here, and it is significant, and then everything to the right of it is still significant as it's being measured. But the only reason these zeros that I've underlined in yellow are there is to let us know where we started, where the measurement lies. So that's rule 4. Rule 4 is that space holding zeros, that's what we'll call them, are not significant. There are other zeros that are also not significant in similar manners. So if we were to put a 0 here, let me underline that previous one in yellow so we can look at that example. If we were to put a 0 there, that one would also not be significant, as it is just there for show. It's there to let you know that the decimal point is a decimal point and not a period from the sentence before, maybe. So this 0 has no significance. 5, 0 to the left of the decimal in a number less than 1 is not significant. Okay, so rule 6 deals with our last type of zeros, and those are zeros to the left of a decimal, but right of the significant. That's not how you spell significant. Figure in a whole number. Trick here is the decimal point is just where we know it is. It's not actually there. So an example of this would be like 200. We know that the 2 here is significant because of rule 1. It has one significant figure there. Now these 2 zeros are not significant. They're essentially just placeholders like we had in rule 4, just on the other side of the decimal. It's saying that, hey, we measured to the 100 spot, but we didn't check the measurement beyond that. So maybe you measured something as roughly 2 meters, but you need to report it in centimeters, so you know it's 2 meters. So you've got 200 centimeters, but you don't know if you had 202 centimeters or 198 centimeters. You just know it was really close to 2 meters. That would be an example of where 200 would have one significant figure. Now, if you measured it to 2 meters exactly, to the best of your ability with whatever device you were having, then what you would do is you would put a decimal point right here and leave it like that, and that would make it look like, let's do that in a different color. That would make it more precise, a more precise measurement, and instead of having one significant figure, it would have 3. So if the decimal is there, all trailing zeros become significant. Okay, now that we know how to tell what a significant figure is, what we need to do is start working on some math problems. Another rule that I forgot that I just remembered would be exact numbers. So exact numbers carry no significance. They are defined. There are 100 centimeters in 1 meter. So if you're doing a calculation with something like that, that is an exact number. There are 12 and 1 dozen. There are 100 years in a century, or 10 years in a decade, 60 minutes in an hour. If you're dealing with an exact number, a number that is defined, then you do not take those numbers into consideration with your significant figures in your calculations. Do not use defined terms for determining final significant figures in problem. Okay, now let's do some problems. We're going to start with addition and subtraction. Both follow the same rules. And that rule would be you round to the number that is the least significant, or you round to the one that is to the number. So round to the number of least significance. And an example of this would be if we were adding two whole numbers, and one's 101 and the other one is 50. We would see that, after we do the math, that this one here is how accurate this top number is, and this 5 would be our number to use for the bottom number, as it is the farthest right significant figure. So since the 5 is the farthest right significant figure, that's the spot we're going to round to. So our final answer would be 150. more often when we're dealing with our measurements in chemistry class, we're going to have decimals than big whole numbers. So if that's the case, we are going to look at it like this. So let's say we have 1.087 plus 2.03. Okay, so we are going to do the math. We get 3.117. Now in this case, our top number, that's 7, is the last significant figure. So that is the measurement of exactness. That's how the spot of significance for that number. And in the second number, it's this 3. So that is how far that measurement was taken, or how significant of a number that is. So therefore, we can only measure to 2 spots past the decimal. So we are going to round to this spot here. We look at our 7, we get 3.12. Okay, multiplication and division. This one, you simply multiply or divide, and you round to the number of significant figures that the number in the problem with the fewest significant figures. So I know those are a bunch of words that don't always make 100% sense, so it's better if we see example problems. So what it's saying is, if you're multiplying a number like 12, and you're multiplying it by 8, and we're going to get 96. So 12 times 8, 96. But if we look at this, 8 only has one significant figure, and 12 has 2 significant figures. So at the end of the day, we need to round the answer to one significant figure because it's got the fewest number of significant figures in our problem. So we're going to have to look at this. So we are going to round to our first spot, which in this case is going to end up turning into a whole nother spot. But so we look at the number to the right of it. The 6 makes the 9 turn into 10. So our answer would be 100, where the 1 is the significant figure. So our answer also has one sig fig now. So we want our fewest number of sig figs to be the same. Another example, if we are taking 2.5 times 3.48, we would be looking at an answer of 8.7, exactly. Huh, that's fun. So we get 8.7 after we do that multiplication, and this, in this case, since we've got 2 sig figs here and 3 sig figs here, we need to have 2 in our answer, and our answer already has 2 sig figs, so we wouldn't have to round it all. Okay, so now let's get into rounding rules. So, rounding rules. 1 through 4, you round down. And 6 through 9, you round up. 0, it stays the same. But what do we do about 5? So we don't want to round up more often than we round down. So what we need to do is have a rule for splitting the 5s in half. So what you do is you always round to the even number. .35, if we were rounding to 2 significant figures, would round to 1.4 because we want a significant, or to round to the even number. So this 5 is going to make the 3 go up. At the same time, 1.45, if we were rounding to 2 significant figures, would round down because we don't want to go to 1.5. That's not an even number. We want to go to 1.4. That's the only rule that you probably didn't learn in elementary school about rounding, because typically 5 and up you round up. But when you're dealing with significant figures, you got to have a rule for the 5, and it rounds to the even number. An easy way to get the right number of significant figures in your answers, especially if you're dealing with very big or very small numbers, is to use scientific notation. Trick to scientific notation is your coefficient has to be between the numbers of 1 and 10 and 1 and 9, and then everything that's in the coefficient is significant. So we have 1.87003 times 10 to the 29th. I don't know. So that would have 6 significant figures because everything is significant. Of course, the way I wrote it, everything would be significant if you didn't have the times 10 to the 29th anyway. And that's pretty much how it should always work. But they're all significant. So if you needed to round that to 4 significant figures, you'd simply just put 1.870 times 10 to the 29th. If you wanted to round it to 1 significant figure, you'd just put 2 times 10 to the 29th. So yes, so scientific notation is a great way to put your answers in with the correct number of significant figures and to be confident that that is your answer. You just have to make sure that you do your scientific notation correctly.